Okay, we are back with number 25. We started on this at the end of the last video, and then the computer froze, so we'll pick it up again. A ball is thrown up from a building that is 800 feet high. Its position, S, in feet above the ground is given by this quadratic function, where t is the number of seconds since the ball was thrown. How long will it take for the ball to come back to its starting point? All right, so I already started working on this. We see here that we've got this guy. He's up on a building. He throws a ball up in the air, and it has some kind of a parabolic arc. Basically, this little dude's gonna, let's move him over. He's gonna throw the ball, it's gonna come up, and it's gonna come back down. So what we really want to know is, how long was the ball in the air? And the way we're gonna figure that out is by determining what this zero is right here. Okay, that's basically what we're going to do. So we need to factor and solve this quadratic equation. Now, there's a lot we could do here. I have an idea. I'm going to set this equal to 0 and then just attempt to divide down these numbers a little bit because they're pretty big. First, I'll just divide by 2. So this would give me negative 16t squared plus 45t plus 400. Then I'm thinking, what else can I divide out of this? I don't know that there is anything else I can divide out of it. 16's factors are 2, 8, 4. 45 is 9 times 5, so there's no common factors even between those two numbers. So I think I'm just going to have to work with these numbers being huge like they are. All right, now, what's the easiest way to solve a quadratic this big? Well, we could try using factoring by grouping, but in a pinch, what we could do is just plug all of it into the quadratic equation. So A is negative 16, B is 45, and C is 400. The dividing out everything by 2 shouldn't change the solutions to the quadratic. It changes other aspects of the quadratic, but it shouldn't change where it crosses the x-axis. Here's the x-axis being the building roof. Okay, so the quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac. And then all of this is divided by 2a. Okay, so we got to plug in our numbers. X equals negative 45 plus or minus the square root of b squared. That's going to be 45 squared minus 4 times a, which is negative 16, times c, which is 400. This is all divided by 2 times negative 16. Okay, so we've got some work to do. 45 squared is 45 times 45. 5 times 5 is 25. 4 times 5 is 20, plus 2 is 22. 5 times 4 is 20. 16 plus 2 is 18. So this is 5, 2, 0, 2, 2, 0, 2, 5. Now I got some work to do over here. I have to wait to do the subtraction. I need to multiply 4 times negative 16 times 400. So 400 times 4, that's going to give me 1600. And then to multiply that times negative 16, right, we'll multiply this out. 0, 0, 6, 3. 1 times 6 is 6 plus 3 is 9. 0, 0, 6, 1. 0, 0, 6, 5. Carry the 1 and 2. So 1600 times 16 is 25,600. But it's negative. So here's what we have. We have negative 45 plus or minus the square root of 2025 minus negative 25,600. Okay, that's really like a big plus symbol in there. And then this is negative 32. So now I have to add 2025 to 25,600. That's 5, 2, 6, 7, 2, 27,625. It's going to be negative 45 plus or minus the square root of 27,625. All divided by negative 32. Now, here's the problem we're going to run into. I have no idea what the square root of 27,625 is. And I don't have a calculator. I can't use a calculator. So this is going to hinder my ability to find the answer because I can't calculate that square root. I could just start guessing numbers. But still, that's a tall order. Let's see if we can't come up with a different tactic. Let's go back to our original quadratic, negative 32t squared plus 90t plus 800. Negative 32t squared plus 90t plus 800 equals 0. I'm going to try something called completing the square. Okay, so first thing I'm going to do is subtract 800 from both sides. Now I've got negative 32t squared plus 90t equals negative 800. And now I'll divide everything by negative 32. That gives me t squared by itself. Now 90 over negative 32, let's work on that fraction. So first I can just cut it in half, and that gives me 45 over 16. We already went through this. There's no common factors. We have 9, 5, 2, 8, 4. None of that can be reduced. So this is just minus 45 over 16t equals. Now here I can cut this in half to be negative 400 over 16 over negative 16, which these will just become positive. And I can further divide by 4. If I divide here by 4, I get 100 over 4. And 100 divided by 4 is 25. So this equals 25. Okay, so the way you complete the square is you take the middle coefficient here and you multiply it by 1/2. Okay, so you take half the middle coefficient, negative 45 over 16 times 2 times 1 over 2 gives me negative 45 over 32. What we do is we take half the middle coefficient, we square it, and then we add that to both sides of our equation. So I'll add it here, plus open parentheses, negative 45 over 32 squared, plus negative 45 over 32 squared. And we'll figure out what that is later. It doesn't matter. Now, this becomes a perfect square trinomial, which can be written as a perfect square binomial. So that would be t plus negative 45 over 32 squared equals 25 plus negative 45 over 32 squared. Okay, now I've got to actually figure out what that is. So the way we square a fraction is we square the numerator and we square the denominator. So I need to do 45 squared. Five times 5 is 25. 4 times 5 is 20, plus 2, 225. This is 20, 16, 18. 5, 2, 0, 2, 2, 0, 2, 5. And then I have to square 32. 32 times 32. 2 times 2 is 4. 3 times 2 is 6. 2 times 3 is 6. And then 9. 4, 2, 10. 1024. So to rewrite this, I have t plus negative 45 over 32 squared equals 25. And then this is now positive because I squared it. It's going to be plus 2025 over 1024. And we can find a common denominator here. We know that the only factors of 25 are 1, 25, and 5 and 5. So finding the common denominator here is going to be somewhat of a challenge. 1024, I don't believe it has any of those numbers as factors. Even if I broke it down, I think I would just get, let's see, we get 5, and then I would get 1, 2, 5, 12, okay. And then, what is this, 256? 2 and 256. 2 and 128. 2 and 64. 2 and 32. Yeah, I'm not going to get anywhere. So none of these factors are going to help me get 25 in terms of 1024. I think I'm just going to end up having to multiply. I'm going to end up in the same boat I was in earlier. I'm going to multiply 25 times 1024. And this can't possibly be what they want me to do. Let's go back and read the problem. Okay, I've got an idea. What if I just assume that this building being 800 feet high is irrelevant because we're saying the guy is up on top of the building and we're just asking how long it will take for the ball to come back to the starting point. So we can kind of ignore the fact that the building is 800 feet high. And let's see if that helps us. So negative 32t squared plus 90t. I'm going to modify this whole problem and just say negative 32 t squared plus 90t and basically plus 0, right? I'm just going to assume that the top of the building is the floor. So I'm ignoring the height of the building here. I don't know if this is going to help me, but it's going to make the math easier. So there's my math now. So now I'm just going to divide everything by negative 32. I'm still going to try to complete the square, but maybe this will make my math easier. So now I have t squared plus 90 plus negative 90 over 32 equals 0, because this 0 divided by negative 32 is 0. Let's see what we can do with 90 over 32. That can become 45 over 16. So I've got t squared minus 45 over 16t equals 0. Now I'm going to take half the middle coefficient, square it, and add it to both sides. I think we already did this. Yeah, that was 2025 over 1024. Okay. I'm going to roll with it and see what happens here. So I'm going to remember take half the middle coefficient, square it, and add it to both sides. So half the middle coefficient would be plus negative 45 over 32 squared plus negative 45 over 32 squared. This is a perfect square trinomial, which I'll write as a perfect square binomial as t minus 45 over 32, the whole thing squared. equals, and this was 2025 over 1024. 2025 over 1024. And now I just need to take the square root of both sides. And I'll have t minus 45 over 32 equals, and now I can take the square roots of the tops and the bottoms. I think 2025 has a perfect root. I think it, let's see if it's 25. 25 times 25. That's 5, 12. So, and this is 10. No, that's 625. I need a bigger number. How about 55? 55 times 55. Let's get, maybe we're getting closer. I don't know. Maybe. Oh, man. So I got too big here. Is that really 3025? Let's see. Maybe I'm tripping myself out. I don't think so. That's 3025. What about 45 times 45? Oh, of course. I squared 45 to begin with. What am I doing? Yeah, this is just going to be losing my mind here. This is just going to be 45 over 32. Wait a minute. Then it will be 0. No, it won't. So it'll be 45 over 32, and then I'll add 45 over 32 to both sides. Okay, so t will equal 90 over 32. It's going to be plus or minus. So, all right, so hang on a second. It's going to be plus or minus 45 over 32, so I'm going to have two issues here. I'm going to have 45 over 32 plus 45 over 32, and then I'm going to have the negative of that, which would be 0. Yeah, this is working. So this is going to be 45 over 32 minus 45 over 32. We would expect that since the starting point is 0, this is going to equal 0, right? But this is going to equal 90 over 32. And let's convert that into a decimal. Remember, 90 over 32 is 45 over 16. And so let's see, how many times will 16 go into 45? 16 times 4, that's 64, so that's too much. 32, how about 3? It's 18. 48. It's too big. So I can just do it twice. So let's see what 16 times 2 is 32. 45 minus 32 is 13. Okay. So this is equal to 2 and 13 sixteenths. But I need 13 sixteenths as a decimal. So I'm going to divide 13 by 16. I'm going to have to add a decimal point, a 0. How many times will 16 go into 130? I don't know. How about 8? $128 is pretty darn close. That's $128. And so this is going to give me 2. Add a 0. So it's going to be 1. So something like 2.81 seconds. Wow. So I think the answer is this. That was a super complicated way of, that is a super complicated question. The key was to ignore the 800, but you still had some pretty crazy math to do. Man, that was hard. Okay, 26. A study of adult drivers finds that it is likely that an adult driver wears his seatbelt. Which of the following can be the probability that an adult driver wears his seatbelt? All right. You just want to pick the highest number. Okay. Which of the following is perpendicular to the line 4x plus 7y equals 23? Okay, this is a little bit, it's like way easier than number 25. So first we need to find the slope of the given line, 4x plus 7y equals 23. 4x plus 7y equals 23. So we just have to convert this into slope-intercept form. It's in standard form right now. Well, first we'll subtract 4x from both sides. So we have 7y equals negative 4x plus 23. Divide everything by 7. So y equals negative 4 over 7x plus 23 sevenths, which we'll just leave alone for now. Now, if the slope m equals negative 4 over 7, the perpendicular slope is going to be equal to the negative of the reciprocal. Okay, so negative 7 over 4 means that my perpendicular slope, which we denote m to the negative 1 power, it's like the inverse slope, but the negative, it's like the negative reciprocal slope, that's going to be 7/4. So my perpendicular slope is 7 over 4. And there's only one equation with 7/4 as the perpendicular slope. So it's got to be this one. What is the solution to the system of equations? Okay, 2x minus y equals 6 and y equals 8x. 2x minus y equals 6. And then y equals 8x. Okay, so first we need to get both the equations in the same form. It doesn't matter. We could solve both for y, or we could put both in standard form. I'm going to put both in standard form. subtract 8x from both sides here. And then I'll write that here. I've got negative 8x plus y equals 0. Now I can directly eliminate the y's by adding. And so this is elimination by addition. So 2x plus negative 8x will give me negative 6x equals 6. I'm going to divide both sides by negative 6. So x will equal negative 1. And now I can plug negative 1 into my original equation. Y equals 8 times negative 1. Plug it into this one. So y equals negative 8. So it's negative 1 and negative 8. The mass of the moon. Okay, so I need to grab this real quick. So here we're messing with this scientific notation. So I just want to explain how I'm thinking about this. So here's my two masses. I can turn the mass of the Earth into a number with, I need these to be the same, okay, in order for me to work with them. So here's how that works. If I move this decimal point over 1, now I have 59.72 times 10 to the 23rd. I can move it over one more time, and I have 597.2 times 10 to the 22nd. So that's what you needed to do. That was kind of the big step. So now you need to divide 597.2 by 7.348. And I just kind of chopped these off, and I divided 597 by 7. And I just saw what I got. 7 goes into 59 8 times. That's 56. 9 minus 6 is 3, 37. 7 goes into 37 5 times. And so I'm looking for a number close to 85, right? Because this would be 85 times larger, basically. And I don't see anything like 85, but here I see 8.127 times 10 to the first. 8.127 times 10 to the first is equal to 81.27, right? Because 10 to the first just means move the decimal over once. So 81, the way I rationalize my answer here is 85 is pretty close to 81. When I'm dealing with these large numbers, I cut off the decimals. So I'm going to go with this one. And finally, 30. What is the correct factorization of the following binomial? 2y cubed minus 128. So let's take a look at that. 2y cubed minus 128. Right away, I need to factor out a 2. Because I can pull a 2 out of both of these terms. So now I'll have 2 open parentheses y cubed minus 64. And I basically remember this but ignore it for now. So now I'm just dealing with y cubed minus 64. Let's write that out in its full standard form. I've got y cubed plus 0 y squared plus 0y minus 64. And so now we're going to just solve this or factor it as if it were a cubic equation set equal to 0. Don't forget about this 2 at the end, but we can ignore it for now. So now I need to think of a possible solution. Remember, we have to guess. And so what my brain was thinking was, I was thinking, okay, 64 is equal to 4 cubed. So I wonder if 4 is a solution. That's what my brain thought. So sure enough, if I plug in a 4 here, I got 4 cubed, and I know that is equal to 64. 4 times 4 is 16. 16 times 4 is 64. 64 plus 0 minus 64. Yep, those cancel out. And so 4 is a solution. Okay? So I guessed correctly that 4 is a solution. So now what I'm going to do is I'm going to put a 1 here and then do synthetic division. I've got 1, 0, 0, negative 64. And then I know that x equals, or I should say y, because there is no x, y equals 4. And so we're going to do synthetic division. Remember, we bring this 1 down and then multiply 4 times 1. That gives me 4. 0 plus 4 is 4. 4 times 4 is 16. 0 plus 16 is 16. 4 times 16 is 64. Negative 64 plus 64 is 0. So this is my resulting quadratic, 1x squared plus 4x plus 16. I tried to factor this, and I just couldn't. All right, I couldn't think of two numbers that add to be 4 and multiply to be 16. So I took a closer look at it. Part of the quadratic equation is this part here, and this is called the determinant, or rather the discriminant, not the determinant, the discriminant. If b squared minus 4ac is negative, then there are no real solutions. So a is 1, b is 4, and c is 16. So we're just going to evaluate the discriminant. Okay, if the discriminant is less than 0, okay, you're going to have complex solutions. So we can't, in other words, we can't factor it. We can't factor it using integers because the solutions are not integers, they're complex. That would mean like they're composed of real and imaginary parts. So let's plug in b squared minus 4ac and see what we get. So b is 4, so I've got 4 squared minus 4 times a, which is 1, times c, which is 16. Okay, so I've 4 times 4 is 16. Minus, and then 4 times 1 times 4 is 64, right? 4 times 16, 64. So this is 16 minus 64. So I don't care what this is. I just know that 16 minus 64 is negative, which means I can't factor this quadratic into real factors, integer factors. I know that it's negative, so it's not even that I can factor it into rational factors. It's going to have complex solutions. In other words, this particular quadratic never crosses the x-axis. So we leave it in its unfactored form. And so let me kind of bring all this back together. We know that one of our cubic solutions is y equals 4. Therefore, one of our cubic factors is y minus 4. Okay. Another one of our factors is going to be this whole quadratic, which I get so used to writing it with x's. It's really y squared 4y plus 16. So this will be y squared plus 4y plus 16. And then don't forget about that 2, right? So that sits here. So this is the full factorization of that original cubic. 2y cubed minus 128. Two y cubed minus 128 equals 2, open parentheses, y minus 4, close parentheses, open parentheses, y squared plus 4y plus 16. Okay, now number 11 was the one that I did not know, and I am completely lost on what we're being asked to do here. I don't even know what to guess because I think I'm missing something. I don't know. This is twice the area of the circle, but then this whole business here, I don't know. I'm just going to guess. I don't know. Let's see what happens here. Well, I'm afraid to complete this because I don't want it to record as completed. I think you can still retake it. I don't know. Before I do that, I want to see if I can retake a quiz. Let's see if it'll let me retake that quiz. Good. Okay, it will let me retake it. All right, so this was practice test 6. Good, good. All right, I'm going to hold off on clicking submit on that quiz because I want to make sure that this remains a fresh quiz for you to take. I don't want to submit that quiz. So I'm going to stop the recording there. I hope this helped you.